Hey there YouTube, Super Brain AK here, and well, check it out. It's a little buck converter module from a server power supply. It was from a fairly older one, same one that I got this 12 volt 23 amp power supply from, that I made into my wall wart buster. But yeah, it's a little buck converter. So I was trying to use the goal of this is to give 3.3 volts, well, 3 volts to my Lacrosse BC700, because it's just a barrel jack there, and if since I have 12 volts here, I can connect 12 volts from that coming off the monitor power supply to a buck converter to this and run it off 12, or even use it portably in a car or on my backpack like I just said. But yeah, that's the goal. So I was trying to use this little one from the raid card of an Power Edge 1850. Yeah, but I can't set it to any higher than like 2 volts. It starts going crazy. It puts a high output power and then shorts out, and then it just flips between that. So I don't know what's up with that. But that's the model number there of the little chip. 6522. Buck and synchronous rectifier, pulse width modulator, PWM controller. 0.8 volt reference. So it's not meant for much higher voltage. I figured twice the voltage that it was originally designed for would be just fine, but apparently not. So there's the module there. So that's a dual N-channel MOSFET chip, and that's the thing. That is a reference diode, well, a Zener diode basically. And then that's a little voltage comparator. So I think that's like 1.5 volts there, that Zener. So it might be permanently set to 1.5 volts. So I will have to like bypass that part with the voltage comparator and everything. So I'm not sure. But yeah, I started using this one, soldered that all up, and it works pretty well. This one is a CS5211 low voltage synchronous buck controller. It says obsolete because it's old. Where's Y? YWW, year work week. Okay, let's find that out. I don't know if you can see that, but it is upside down. ZRYG205. So 205. So 2002, or the second year. I'm not sure exactly how those work. But yeah. So this one's a 1 volt reference, and it works pretty well. So I've got two solid capacitors there that I stole from the board that this was sitting on, the 1850 RAID board. The input is a, where's it? Oh, it's behind the barrel jack there. 16 volt 230, I think, microfarad. And then the output is just there, 6.3 680 microfarad. So obviously not high voltage, but yeah, doesn't need to output high voltage. That's a little trim pot. I think that's 10K, which I used from one of these, which is my little buck converter modules. They aren't terribly efficient or can handle that much power, but they work surprisingly well. Here's it for reference. The other one, what does it use? $28.96. $26.96? LM2596. That's what it uses. But yeah, this one I have sort of configured for plugging into my laptop battery that I keep in my backpack, so I can get 12 volts and then output the voltage there. Whether it's to power up my arc reactor. I have a little LED strip and a triangle, red LED strip, so I'm halfway Tony Stark. But yeah, anyway, I don't know if I just told you, but the goal of this is to power up my BC700, this, and at 3.3 volts. So the other one didn't work, so I made up this one. This one works. The only problem is, if I show you this efficiency chart, it draws 2.4 watts idling. Now, as you can see, as you start drawing more wattage, the efficiency is still really high. The only problem is it idles. So kind of the more you draw from it, the more efficient it is, because it has such a high idle. But as you can see, with 20 watt load, it's wasting almost 0.7 watts, less than a watt. But of course it's idling at 2.4 watts. So, man, it's pretty cool. But I don't think I'll be able to use that for this, because this doesn't draw that much power. I believe it's 700 milliamps times 4, so 71428, 2.8 amps. So at 3 amps, I don't know how many watts that would be. 3 times 3.2, 9 watts. So at 9.8, it would be losing 2.5 watts. 9.6 over 2.5. 3.8 times. That's the wrong way. So we've got. Let me pause this and figure it out. Okay. So it's only 75% efficient. 25% is being wasted. That was 2.4 over 9.9. Well, 2.5 over 9.9. Yeah. So it's 75% efficient. Now, of course, 3 over 20 is 15. That's 85% efficient. So obviously it will be more efficient at like 40 watts. It'll be pretty darn efficient, like 90%. But not doing this piddly little amount. So I need to find something that can handle 3 amps. Almost 4. 2.8, yeah, 3 amps. At idle's very low. So I guess I might use one of these. This one I have strapped to a little heatsink. So yeah, we'll see how it goes. Yeah, before I go, let's watch it draw some power, I guess. That's that power good. The power good is actually interesting because that's with its own reference. It has a little reference diode as well. It's that one transistor in the middle, and the power good is there on that top transistor, which is being fed by that transistor at the bottom. So yeah, doesn't have any real power good from the chip itself. So I'll just leave that disconnected, and negative goes here in the kind of middle. Connect that up. 12 volt. Alright. 12 volt in. Output. Well, input. Whoa. So yeah, for the load, I have 4 resistors, 1 ohm, 1 ohm, 2.2 and 2.2 or thereabout. 2.2, 2.2, okay. So 2 2.2s and 2 1s, which draws about 6 amps, right about there. So 12 volts in, coming from this 1.5 amp 12 volt supply. And yes, I'm going to be drawing more than that. But yeah. Boom. So that's input current. That's output voltage with reference to there, which I haven't seen rise very high. Then output goes through here, through the current to the resistors and back. So yeah. At idle, no current drawn, it's drawing 200 milliamps, which is a pretty high idle current. So if anybody knows why it's idling so high, please let me know. I don't see how that's possible to just draw that much current just idling. It shouldn't even really be outputting at all. It should just be switching a little bit of power into the coil and be done with it. So it might be like drawing power back out of the coil to keep the voltage out, low enough. But yeah, 12 volt cooling fan on a resistor to keep those guys cool and keep this guy's cool, because it's drawing 3 watts thereabout. Check the temperature. Yeah, already it's at 50°C. But buzz, you can hear the fan slow down a little bit. 5.8 amps, about 3.3 volts, drawing 1.9 amps from the 12 volt supply. And yeah, the voltage in does drop pretty high because it's going over a small barrel jack through the breadboard, and so yeah, 11.6 coming in right here. But yeah, 1.9 amps in, 11.6, 5.76 amps out. I'm at 3.3 volts. So it can handle the power. It just idles terribly. So yeah, thanks for letting me ramble. Make sure to like, comment, and subscribe. Let me know why the heck it does that. If there's any way I can maybe get its idle current down lower, that would be appreciated. And yeah. Oh, one other thing I'm sort of looking for are constant current LED drivers. That can be controlled with a PWM input. So that way I can set one up there on the light bar and then have these 3 wires come down to the board with the SGL8022s, and yeah, not have any flicker whatsoever. Actually, that's not flickering because it's maxed out, constant 12 volts. But yeah, let's check the temperature before we go. No, 63. It's on the coil there. It's where the most power gets wasted. 45 on the MOSFETs. Yep. So, active cooling only. Yeah, thanks for watching. I'll see you later.